This is problem number 1 from our midterm review. Here we are asked to find the equation of the ellipse in standard form that has vertices at plus or minus 5, 0 and foci at plus or minus 4, 0. Using this information, the simplest way to find the equation is to just create a quick little sketch. I have an x-axis, or rather a y-axis, and an x-axis. And I'll go ahead and plot points to represent what we've been given here, foci, or the vertices rather, at 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, negative 5, 0. Those are my two foci. I can see right away that my center is at the origin, right, halfway between the two vertices. So I know a lot already. I know that the value for the variable a is this distance from center to vertex. I also know the coordinates of the center of the ellipse now are 0, 0. So I can start filling in values for some of the variables. H equals 0, K equals 0. Those are the coordinates of the center. A, the distance from the center to the vertex, is 5. And if I plot one or both of these foci, I have one here at negative 4, one at positive 4, I can see now that the variable C is equal to this distance from the foci to the center. Notice that it doesn't matter if I use the positive side or the negative side. We're talking about a distance here. C equals 4. B, we don't know. We're going to need a formula to find B. And we have that. I've included in here, let's see, here's a copy of a more complete formula sheet. This is the formula sheet we used during the unit, and I will post this to It's Learning for you. We can see on here that we have this formula. If the foci are known, use c squared equals a squared minus b squared to find a or b. You have that in your notes on the little half sheet that we got in class on Thursday. So the foci are known, so we're going to use that formula to find the value for b. So right here we say c squared, well actually we don't need c squared, 4 squared equals a squared minus b squared. And again, so we're going to use the formula here. We're going to plug in the values that we know. 4 squared equals 5 squared minus b squared. Solving this for b, I won't put you through the whole process, but b squared equals 9. Therefore, b equals 3. We now have all the variables that we need in order to fill in the formula. Let's take one last look at our formula sheet and see which formula to use. We see from our sketch that our ellipse is going to have a horizontal major axis. We know the distance to our co-vertices now. We could go ahead and plot that if we were asked to. Of course we weren't, so this is not necessary, but this is a rough sketch of what this ellipse would look like, right? It has a horizontal major axis. So we're going to use this form of the equation right here. The x over a and y over b. Filling in the values that we have x minus 0 squared over 5 squared plus y minus 0 squared over, let's see, 3 squared equals 1. But we can simplify this a bit. We don't need the zeros, and we can expand these exponents to give us x squared over 25 plus y squared over 9 equals 1. You could plug this into your Conics app on your graphing calculator to verify that you get something that looks like this, and you're good to go. Next up, problem number 2.